Hello, hello, guys. Really great to be back. This is the third week, right? And we've been doing some amazing things. Okay, so today we're going to take it a little bit further. We're going to do something in Python class. But before we start, I would have to go through everything we've done from the start, from week one. And of course, if you have any issues, any challenge, and if you've had any challenge so far, don't hesitate to just drop that comment and we would help out. For those of you who have assignments and you've not submitted them, please endeavor to submit them. The email will be placed on this screen, and then you just copy it out and then send it there, right? I'm looking forward to seeing what you guys have done, what challenges you had, and how we can make you get better, right? Um, so yeah, Jonathan, Inyemabo, if I remember correctly, Betty, and everyone, right? So let's quickly dive in. I'm going to share my screen and then run through what we did, what we've done so far, and what we're going to do today. Great stuff. Okay, 1, 2, and okay. Okay, fantastic. All right, so let's go to week one. Okay, so week one we talked about print statements. We talked about print outputting, or the print statement out helping you to output whatever is happening at the back, or what the computer is doing behind the scene. And we walked through the print syntax. All you have to do is type in print and type in parentheses, and then put your, if it's a string, if it's an integer, if it's a Boolean figure, if it's a float number, all you have to do is just put it into the parentheses, and then run that code. Before we go a little further, I think people are having issues with Google Colab, and it's so easy. Like, it's the easiest thing ever, right? All you have to do is just go into a tab, open a tab, and type in Google Colab, right? That's all you have to do. Once you click enter, it'll take you to this page, and then you just click welcome to Collaboratory, right? This for you would be empty. I think you would see just a welcome to Collaboratory link here, and once you click that, it will take you to this page at the back, right, behind the overlay. Or you could actually just click new notebook, and then it will create a new notebook for you automatically, and it is connected directly to your Gmail account. So this is powerful because everything you work on automatically saves into your Gmail account. Just like if you're doing a Microsoft Word, or you're doing a Google Doc, or you're doing a Google Excel, it automatically just saves. So it's powerful, incredibly powerful, right? So yeah, so that's how to just set it up, and then use it. Once you come to this page, all you have to do is go to go to file, go to new notebook, and then it opens a new page for you, and you start coding. That's all. And you have access to pretty very powerful compute, that your probably your local system does not have, right? You have access to GPUs, which means faster compute, or TPUs. You have access to, you could connect to your drive and get data from your drive, directly from your drive. You could, it's pretty amazing, right? So those of you who are using PyCharm, great, but I would like for you to learn to use Colab. It's actually much more simple than it's simpler than the other IDEs. If you're using VS Code, fantastic, but I'll need you to migrate to Colab. All right. Okay, so back to print statements. So we're done with print statements. We talked about data types. We talked about strings, integers, floats, and then we talked about booleans, right? We did talk about booleans. Yeah, we did talk about booleans right here. Okay, so I'm sure you know how to implement strings just using these quotation marks, putting whatever you want to do into a quotation mark. It's the same thing, either if it's double quotation mark or it's single quotation mark, it's still the same thing, right? And of course, if you want to run, these are cells, right? If you want to run each cell, all you have to do is either click this button here to run it, or you type, hold down on shift and then press enter. That's all. Okay, so these are the data types. There are more, but these are the ones most used ones, right? Okay, so that's what we're focusing on. All right, so then we talked about indexing. Indexing helps us to find the position of, or get elements in certain positions in your string, in your integers, in your floats, right? So we talked about this starting from zero. Index zero is the first item, and index minus one is the last item. So it's from zero, you're counting from left to right. For minus one, or for minus one, you're counting from right to left, right? Great. Okay, and then we said if you, for example, this course 5 or index 5 will take you to 0, 1, 2, 3, 4, 5, and then give you the n, give you an n here, give you this n here, and then print it out. Minus 3, minus 1 is E, then minus 3 will be minus 1, minus 2, minus 3, which will give us an R here. And we printed it out here using the print statement. And then if you want to print more than one item, you could just use the index, and then the index of your first item and the index of your last item, separating it with a column, right? So that means print everything between 0, in this case, print everything between 0 and 15. Simple stuff. In this case, print everything between index 3 and index 10. Great stuff, right? And then we talked about the fact that even spaces are indexed too. Spaces have index, right? That's why you'd see this HIN space LE. And then we also talked about the fact that the last item does not get printed, right? Everything, it starts from your first index and then up until the item before the last item, right? Then we talked about variables. Right. We talked about variables. The concept of variables is just putting in Boolean figures, putting in strings, integers, and floats into a bucket so that you can use it later. A bucket or a container or a store, whatever you want to call it, right? So that you can use it later. All right. So we're saying, in this case, we're saying we're putting 1099 into, or 10.99 into price, and then we're putting 13 into age, and putting Daniel into name, falls into is published, right? Great stuff. And then once we do that, you can then print them out one by one or together, whichever works for you, depending on your use case. And then we said if you try to print out something that you haven't defined, in this case, these are definitions. Equal to makes it, you define price as 10.99. If you haven't defined it and you try to print it out, you get this kind of this kind of error called name error, meaning that name color is not defined, right? So you need to define it. You need to give it something. You need to pass in a data. You need to pass in data into it, right? So in this case, we're passing in blue into color. Great. Okay, so then we move to impute statements. We talked about the fact that impute statements is used to get information or data from the user, or it's an interactive statement. It helps you get information from the user or data from the user, and then use that data to do something, right? So let me just go ahead and open this. Yeah. Okay. So in this case, we want to get in what the person's name is, and then we'll put whatever is imputed into the name variable, right? And so we said if you run this, you will get you get a box asking the user to impute whatever is being asked of, right? So in this case, it was asking for my name. I put in Daniel, and Daniel was stored into the name variable. And so if when I print the name variable, it brings out Daniel, right? Fantastic. These are pretty simple stuff. And then we said if this variable name is printed or it's stored as Daniel, if you pass in something else into the name variable going forward, it will automatically change what is inside the name variable, right? It's as simple as that. So you want to be careful of that when you're coding. Okay, so the next thing we try to pass in, well, we did pass in a color into this color variable, and then we printed it out. But in this time around, we printed it out in with all other what do we call it now? Other, should we say other data, or within a string? Let's just put it that way. We got the information, passed it into color, and then outputted it in, or put it into a string, and then I printed everything out. So in this case, we have Rahima likes. Oh, Rahima, I hope you're in the class. Let me see. Is Rahima here? Oh, Rahima. I'm waiting for Rahima. Okay, so Anne, so nice to have you. Okay, yes, I'm going through the recap. Allow me. Um, okay, so I just explained the process of getting collab, but I'll quickly touch it again. Okay, but meanwhile, before I go on, guys, I need you to send your email address, right? I need you to type in your email address so that you can join. Today we're doing something a little different. You're gonna come up stage with me, and you're going to be able to share your screen. So if you're having issues, I could help you through. But for that to happen, you need to send in your emails, or just type in your emails, and then we'd send you the link to come on stage, right? And then we could work together. Okay, so back to Rahima. So yeah, Rahima likes pink color. I think she said she didn't like pink color last week. I think we got pink color wrong, if I remember correctly. I think we got pink color wrong, but it's fine. But in this case, we passed in pink here, and then we put it into this color variable, and then we pass that color variable into a formatted string. This F here means a formatted string. We could actually just remove the F and just put Rahima likes so and so color. But in that case, we won't be able to pass in this variable here into this place, right? But for us to be able to pass in variables, we need to put it into a formatted string. So this F is compulsory, right? Okay, so with that, we're able to talk about solving this exercise. Get the name of the user, store it in a variable called name, print, and then print that name. Again, this is a formatted string. You can see the F here, and then you can see hi, whatever was stored in name. The same thing here too, and whatever was stored in name, or whatever was stored in color. Right, so then we jumped to, with all that, we went straight to week 2. Let me just make this smaller so that it's easier to just navigate through. Okay. Are you seeing my screen? I'm actually sharing my screen. Hey guys, can you see my screen? Can you see my screen? Let me just okay, I'll just quickly stop sharing, and then I'll restart sharing. That should solve the problem. Interesting. Okay. So I just stopped sharing, and I'm going to restart sharing. Share screen. Okay, so I just started resharing. Oh wow, so that means I have to recap. I just started sharing again. Can you guys see my screen now? Can you see my screen? Hello? Interesting. But you can hear me. Okay, so I think I started sharing. Oh wow, it's a technical problem. Okay, it's a technical problem. Sorry about that. Okay, so that means I might have to go through the process again. Okay, wow. Okay, so I'll just assume that week one is already covered. So for um, week two, you okay, so we talked about conversion, right? So we've talked about data type, but then there's sometimes we might need to convert data types, right? We might need to change them for us to be able to use them for some certain use cases. So right, so we talked about converting int to float, maybe int to float or float to integer. We talked about converting maybe strings to boolean. um yeah, so sometimes you might need to do that conversion, right? And so we just talked about that in a little detail. Okay, so for example, birth year. So somebody passes in his birth year into the impute statement and then it gets stored as into this variable, right? But then it comes in as a string. So how do we move that from a string to, for example, an integer? So we can do integer calculations, right? Integers are numbers, strings are characters, so they are like words. You can't add word 10 to word 10, but you can add number 10 to number 10, right? So you need to convert it to numbers, right? So you can do calculations. So in this case, you can see that um, we passed in the year, in this case 1960, Nigeria. Okay, Nigeria's birth year 1960. And then the type, we checked the type, it showed us that the type is a string here, but then we changed that string to an integer using this integer, this int um, method here, right? Um, so we passed the birth year into it and told it to convert it from a string to an integer, right? And then once you do that conversion, then do a subtraction, right? Subtract it from 2021. And then whatever you get, put it into the age variable. And at the end of the day, print out the age, right? So that's what happened here. That's why you see 1960, birth year is 1960. Um, it's a string, it comes in as a string, it's converted, and then it's calculation is done, and then it's printed. The calculation is printed, passed into age, and then printed out. Right? So just close that out. And then we talked about math operations, right? Basically, math operations are addition, subtraction, multiplication, division, exponentiation. Basically, well, these are symbols you're familiar with. You're familiar with the plus sign, the minus sign, or hyphen, right? This is the divide sign, this is the multiplication sign, and this is the raise to power, in this case, exponential or exponentiation. So, um, different languages have different syntax, but for Python, this is the syntax, right? So once you do that, again, whatever is gotten is passed into this variable, into this variable, into this variable, and then we got to print everything out one by one. First off, does everybody have this Colab notebook? Everybody should have this Colab notebook. Everybody should have this Collab notebook. Those people that were around last week have access or got access to it. So with your emails, the Collab notebooks will be shared to you, and all you have to do is save it into your drive. We talked about that last week. So saving it into your drive basically means you download. Once it's sent to your email, just download it. You would see an arrow sign on the notebook, right? Just click that arrow sign, downward facing arrow sign. Once you click that downward sign, it'll download into your system, and then you have to upload it back into your drive. So once it's in your drive, all you have to do is should I go through this process again? Okay, all you have to do is go into your drive. Let's test it out. So it comes in as, say, all you have to do is just click new and then click file upload and then find that file. Okay, this was an example of what we did last time. Okay, yeah, so it comes in as Python underscore class .ipynb. So all you have to do is click on this, or both of them anyway. If you're in deep learning class and you're in Python class, you could just click on the two of them and then click open. Once you click open, okay, so once you click open, it'll save on your drive, and then once it comes into your drive, you can see it like this, and then just double click on it, and then you have access. It will just open this for you. So yeah, okay, so it's as simple as that. Okay, so comparison. So comparison is greater than, less than, equal to, not equal to, greater than or equal to, less than or equal to, right? So this is the symbol for greater than. So this is going to save a Boolean value. So it's going to either tell us if the statement is true or false. So in this case, 5 is greater than 2. So it's going to store it as true, right? In this case, 20 is less than 5. That's false. So that means false will get stored into this Boolean 2. Okay, let me do this so it's better understandable. In this case, this is saying equal to here, right? 7 is equal to 4. That's false. So false will be saved into Boolean 3. In the next case, we have 5 is not equal to 3. That's very true. So true will get saved into Boolean 4, right? And then for greater than, 3 is less than or equal to 5. Or 3 is greater than or equal to 5. Well, the two statements are wrong. 3 is less than 5 and 3 is not equal to 5. So both of them are wrong. So false, it'll be false here. But in this case, 3 is less than 5, true. 3 is not greater than 5, but one of the conditions is satisfied. So true will be saved here. All right, so that's why we have these figures here: true, 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 false, false, true, false, true. All right, in case I'm running too fast, you could always revert to the last class. Okay, so this is where we stopped last week, and we didn't get to touch this in as much as I would have loved us to touch it, right? So I'll do a quick explanation. In this case, we're storing false into is hot, and then we're storing true into is cold. So if is hot, print it's a hot day, print drink plenty of water, right? If it is cold, print it's a cold day, print wear warm clothes. If it's not hot and it's not cold, else print it's a lovely day. And when you're done with all that, print enjoy your day, right? So in this case, the only thing that is true here is cold. So this is the only one that will get, that will be, this is the only condition that is satisfied. So it's only this that will be printed. That's why we have it's a cold day, wear warm clothes, and then at the end of everything, print enjoy your day, right? But if we change this from true to false, it means that this is false, this is false, that means this one will be true, right? So this is the only one that will get printed. It's a lovely day, right? And at the end of everything, enjoy your day. Okay, if we change this to true, that means his heart is satisfied. This condition is satisfied. So that means this one will be printed. The rest of them would not be printed, right? If these two of them are true, that means this is how to be printed, is code will be printed, else will not be printed, and print enjoy your day will be printed. So let's just try that out. Oh, okay. So only one of the ifs can be satisfied at a time. So in this case, is hot is already satisfied, so it prints it's hot, right? Because you're saying if it's not hot, if it's not hot, or if this else if means else if is hot is not is false, then come to look at what I have here. That's what else if means. If the previous condition is false, come in and look at what I have inside my house here, right? So that's why it's just is hot that is printed. Okay, you can always revert it from the last class to understand this better. And this is just a short explanation of what I just explained. So we're just going to skip that. So in this case, we're going to learn to use comparison operators, and then we're going to use if statement at the same time. So in this case, we're saying temperature is 35. Yeah. Something is running. Something running. My RAM. You can see my RAM is turning yellow. Okay. Okay. So yeah, temperature is 35, right? We've passed in 35 into this variable called temperature. So that means 35 is here, right? Now they're saying if 35 is not equal to 30, right? Print it's a hot day. Otherwise, print it's not a hot day. So if this is true, print it's a hot day. If it is false, print it's not a hot day. In this case, 35 is not equal to 30, which means it is true. This statement is true here. So that means it's going to print it's a hot day. If I say, if you put in 30 here, let's try 30 and run this. That means this is false. We're saying if 30 is not equal to 30, print it's a hot day. But 30 is equal to 30. Right? So, but if we had done this, so this means if 30 is equal to 30, print it's a hot day. Otherwise, print this. So in this case, it should print it's a hot day. I hope you guys understand this. If it's a little fast for you, just go back on the video and watch it again to make a little more sense for you. And then we talked about doing your assignments or doing the exercise. Just close this so that it's easy to scroll through. Okay, so if name is less than 3 characters long, so you're supposed to take in the name of the user, right? So I'll just quickly walk through this. Let's code it out. Name takes in an impute statement. Say, what is your name, right? So it takes that in. If name is, so let's come down. If name is less than, so is less than 3 characters long. Okay, so to get the Okay, so let's do. Okay, fantastic. Let's do this instead. Three. Now, we didn't talk about learn, right? We didn't talk about learn. Learn basically, I expected that you guys would do some research on it, right? So learn basically it gives you the length of your string, right? Or the length of your variable. So in this case, we're saying if the length of name or length of the characters in name is less than 3, right? You print, uh, let's use, okay, in this case, we're going to format name must be at least 3 characters, right? And then you ask again. Oh, we didn't talk about otherwise if it's more than 50 characters long, name can be a maximum of 50 characters. Okay. Okay, so to make it simple, let's just do this, right? Um, let's else if the name is greater than 50 characters, print name can not exceed 50 characters, right? Okay, let's see what else is there. Else name. Okay. Else print mm, name looks good, right? Let's try this out. Yeah, this should be good. Let's see. But then there could be an error. So say my name is W E. Name must be at least 3 characters long. Okay, let's do it again. Say in this case my name is Daniel. Name looks good, right? So name, that means what I'm doing is I'm saying the name must be between 3 characters here, right? And 50 characters long, right? So let's try making name much more than 50 characters. Let's do, it prints out name cannot exceed 50 characters, right? But if it's within this frame, it'll print name looks good. Now, this is supposed to be the basis for more complex things, but this should be pretty simple for you if you spent a little time on it. Okay, so that's that with the exercise. It was just that simple. Okay, so we're going to talk about um, data structures and loops today. Pretty simple. So list is basically a way to keep data, to keep more than one data. Sometimes you might want to keep several names into a particular place or in a particular place or in a particular variable. Sometimes you might want to keep several items inside a particular variable. So that's what you need data structures for. You can put in a lot of data into, in this case, a list. You can put it into a tuple, you can put it into a dictionary, you can put it into an array, right? We'll talk about that in more detail. So there are several things about lists, right? The first thing you need to know about lists is, okay, so let's do this. Number one, okay, I'm going to write comments, right? I'm writing comments, so I have to use this hashtag here, right? So that it doesn't give me an error sign. So lists are mutable. I'll explain what that means. Data structures, right? So that means you can change them, right? You can change them. Um, you can manipulate lists a little bit more. They are used most of it more prominently for simple tasks because you can do a lot of, you can change them, right? So that's what mutable means. You can split them, you can manipulate them, you can change the item inside you can remove a particular item and put in another item in the place of that item, right? You can do more manipulations inside a list as opposed to maybe a tuple or a dictionary or an array or hash tables or queues or hash maps or what have you, the many other data types we have, data structures we have, right? So you could read more up on lists, but I don't want to spend time on explaining what they do. I just want to show you what they do, right? So if I run this cell and I print out name, you see that I've stored in Daniel, Sarah, James, and John, right? Now, if I wanted to call out the first item, remember how we do it? We just use the square brackets and then we put in the zero, right? First item, Daniel. If I wanted to call the third, the last 0, 1, 2, 0, 1, 2, 3, I wanted to call in the last element, John. If I wanted to do something, this should give us the last element too, right? So again, it's like what we've discussed above when we talked about indexing, where in this case you're indexing items in a list, right? So that's that about that. So let's talk about tuples. So tuples most times I use when you don't want to change the items inside the list. You want it to be say, should we say permanent, right? You want it to be permanent, right? So in that case, you can use tuples. They are immutable, right? So you can read more on that. So it doesn't take the time. Again, you can do the same thing we just did here to get the index. It's as simple as that. Let's do 2. It gives us the same thing, right? You see? Oh, in this case, let's call this name list. So that means we need to put this as the name list, and then let's call this name tuple. Right? Okay, so, and let's call this name dict. So it's more, I'm sure you know why I'm doing this by now. I like it arranged. Okay, so, okay, in this case, sometimes you might want to pass in, sometimes, just allow me, okay? You might want to pass in keys and values, right? So, for example, you want to take in the record of the employees in an organization, or you want to take in the record of students' scores, right? In this case, you could put different names and then put their scores behind them. So that means anytime you call out, so if we check it out, let's pass that into name dict and name dict square bracket Daniel. This should give us, okay. So you can see we're calling out what was stored into Daniel or what is stored with Daniel. Everything on this left hand side is the keys, are the keys. Everything on the right hand side are the values, right? So key value pair. Um, if you want to check out, say let's check John. 85 is stored into John, right? So that's how powerful they can be. Um, the next one we're going to talk about is, last but not the least, is an array, right? To define arrays are ways to keep numbers, right? A large amount of numbers. It could be, say, 100 items long, or they could be 1,000 items long, or they could be 1,000,000 items long, right? So a very good way. And if you want, we could have as well just have studied this in a list, right? But lists are usually slower than working with lists is usually slower than working with an array, right? So that's why if you have it might not, the difference might not be very clear if you have just 10 numbers in a list. But when you have 1,000,000 numbers in a list and you want to do operations on that 1,000,000 numbers, right? You need something that works faster than a list. So that's where arrays come into play. So arrays are used to store numbers, right? Float numbers, and then if you're in deep learning class, arrays are used to store in float values, the float values that we use for, or when you pass in an image, it converts that image into an array of numbers, right? And then it's that array of numbers that you feed into your neural network, right? We'll talk more about that in deep learning class. So that's the power of arrays. If you're using lists, you could do it with lists, but it will be extremely, extremely slow as the number of items you add increases, right? So and then to define an array or to make an array, all you have to do is import numpy as np. Numpy as np is a library, right? It's a Python library for numbers. That's why it's numpy, right? And then with numpy.array, open your bracket, and then pass in your list of values. In this case, we have np r1 and np r2. We're saying store this 1 and 2 into the array, np array 1, and then we're saying store this other set of numbers into np array 2. Now, there are many things we could do with this, but that's beyond the scope of this class. This class is just to let you know that this is a tool you can use, right? Working with the tool, you need to do more exploration beyond the class. All right. So if you want to check the shape, if you want to check, okay, shape could be a little misleading. Okay, so in this case we have, let's start with the np array 2. We have 2 by 2, right? So what we're saying is 2 rows by 2 columns. So in this case we have 1, 2, and then we have 1, 2, right? In this other one we have just 1, 2, right? That's why we have 2 here. Again, beyond the scope of this course. So I'll just quickly jump over that because you most likely will be using an array anytime soon. Okay, so loops. Now, loops are, supposing you want to go through the items in a list, right? And you want to bring them out. You want to do things with them, right? That's when you use loops. There are 2 types of loops. There are for loops and then there are while loops. The idea of while loops is go into a loop, keep going round and round. That's what's called a loop until a certain condition is met. So let's break this down. So in this case, we're passing 1 into the I variable, and then we're saying while I is less than 5. In this case, I is 1, right? The first at this point, I is 1. So while 1 is less than or equal to 5, yes, 1 is less than 5. So it will go into the loop. It will enter into the loop, right? Print I. And then once you print the first I, which is 1 is less than 5, print 1. Then this line tells us that after you've printed 1, add 1 to I. So I here is 1, but add 1 to it. That means I is 2 now. So now that I is 2, take it back to this second line here and put in 2 into it. 2, while 2 is less than or equal to 5. Yes, 2 is less than 5. So yes, that's true. So it's going to go into the loop again and then print 2 and then come down here and add 1 to 2. It becomes 3. It goes back up again. 3 is less than 5, so it's going to enter. It's true. It's going to enter into the loop again. Print 3, come down, add 1 to 3. That's 4. 4 is less than. Take it back up. 4 is less than 5. Okay, that's true. It come back in. Print 4 and then adds 1 to 4. It becomes 5. Takes it back up. 5 is not less than 5. 5 is not less than 5 here, but 5 is equal to 5. So yes, that's still true. So it's going to come down and print 5 and then come here and add 1 to 5. That's 6. Take 6 up. 6 is not less than 5. 6 is not equal to 5. So it will come out of the loop, right? So until this condition has completely been met, this condition here has completely been met, it will not stop. It will continue to go through the loop. And then we said, after everything, after you've gone through this line as many times as it needs to run, print done. So let's run it and see what happens. Fantastic. Do you say, so we started with 1. I've explained the process, right? Started with 1, went in, print 1, added 1 to 1, took it back up. Yeah, 2 is less than 5. Did the same thing. 3 is less than 5. Did the same thing. 4 is less than 5. 5 is not less than 5, but 5 is equal to 5. So yeah, that's still true. You printed out 5, right? And then tried 6. 6 did not work, so it came out of the loop. It's just as simple as that. Okay, so for loops is a little different, but it's still a loop, right? So for loop, we're saying go through the items in this case. First of all, we're putting in several items into this name variable. We're putting in Daniel, Sarah, James, and John, right? So we're saying for item in name. So for item in name, print name. So what it does is it goes into name. Daniel is one item in name, so it will print Daniel out. The next item is Sarah to print Sarah out. Next item is James to print James out. Next item is John to print John out. And then once it gets to the end, it's going to stop. So let's try it out. Yeah, just say, so it's printing them at different lines for item in name. So it's come here, print, come here, print, come here, print, come here, print, right? So that's how for loops work. It's as simple as that. So let's try something let's just add something more to it, right? So in this case, we're passing in a list of values, number values into triangle. So in this case, we have 1, 3, 5, 7, and 10, right? These are 5 items. And then we're saying for num in triangle. Now you could call this anything, actually. You could call this for X in triangle, for dash in triangle, for asterisk in triangle, for W in triangle, anything you want to call it, but so that your code is understandable when somebody else is reading it, right? That's why you have to use something that is people can relate with. So that's why I'm using number here, right? So it's easy to explain. For numbers in triangle, for num in triangle, print X, right? Let's do this first and see what happens. Let's stop it here and comment this out. Right, you see that? So it went, yeah, I know it's a little confusing. It went in, first item, it printed 1, right? Next item printed 2, next item printed 3. If we had done this, you know what, let's start with this. Print num. I know this would be a little confusing. That's why I have to break it down. If I'd done this, right, it will print out the different numbers inside. Okay, so see a simple way to, to conceptualize this. Passing 1 into num, put it into num variable, right, and print that variable, right? Then go back again, put 3 into the num variable and print 3. Then go back again, put 5 into the num variable and print 5. Go back again, 7, and then go back again, 10, right? That means at this point, num is at the first point, num is 1, next point, num is 3, next point, num is 5, num is 7, num is 10, right? Cool. Now let's add something to it. Okay, so if we do this, you have 1, it prints the first line, then prints x, right? Which is okay. But what if we now multiply x by num? Remember, num here is 1 the first time, num is 3, num is 5, num is 7, and num is 10. So if we do this, it should make better sense. Good, fantastic. So you can see when num is 1, x times 1. When num is 3, x times 3. When num is 5, x times 5. When num is 7, x times 7. When num is 10, x times 10. Right? And then it looks like a right angle triangle. Now, if I wanted to comment this out, again, print statement helps us see what's happening behind the scene. But in this case, we don't necessarily need this. If you understand it, you don't necessarily need that. You could just run it and then get your figure or get your diagram, right? So this just helps us see what's happening behind the hood. That's what this line is for, right? So I believe I've explained that, and I believe this next exercise should be pretty easy for you. Create a list of 30 numbers from 1 to 30, right? So that means your list here should be 30 numbers long. So from 1 to 30. So it's 1, 2, 3, 4, 5, 6 down to 30. Use a for loop to print out the first 20 elements. Yeah, this is a little complicated. So in this case, we're printing out everything in the triangle. But how do we print out just a section of the number of the items in the list? How do we do that, right? That's something you're supposed to research. Then after you do that, the next thing you can do is, or you should do is, multiply the first number and the last number in the list using their index. It's as simple as that. So this doesn't fall into the loop. This does not fall into the loop. This, you know what? Let's make it more explicit. Okay, let's do this. Part 1, and let's do this. Part 2. Okay, use this. But I like for this to be bold. And then I like for this to be bold too. So this should make a little sense, a little bit more sense. So part 1, do this, and then part 2, do this, right? Pretty simple. Right, so I guess by now it should be getting simpler for you. Next week we'll be working on functions and classes, and then we can start doing a simple project with all the things we've learned. So I'm just going to quickly run through everything again, a very sharp and quick recap, and then get to see if you have any questions. Okay, again, list helps us store more than one data into a list, and then we can use that to do what we want to do. Lists are mutable, tuples are immutable. That means they are not you can't manipulate them as much as you can manipulate lists, even though they look alike. And then you can use index to call or to get the different items in the list, right? Then dictionaries are used to keep or store key value pairs. So there's a key and then there's a value. You could call out suppose you want to call out all the keys. This should work, right? What if we do this? Yeah, so you want to call out all the keys. It will show you all the keys, right? That's on this left hand side. If you want to call out all the values, you want to see them, because there are times where you might need this. You could just do this, and then you have all the values. Again, you could iterate through this. That means you could use your for loop and go through this. Let me do this for num in dict dot values print num, right? Yeah, print num. All right, so you could iterate through it. It's a list again, so you could iterate through it. Um, Arrays are for numbers, storing numbers. Loops are for going through, doing something over and over. While loop is you keep on doing it until the condition is met, until condition is fully met or completed. Then it will stop. Loops are for going through the items in a variable, the items in a bag, and getting those items or doing something with those items, right? And then you can work on the assignment. So I'll just quickly jump to um, and see if there are any comments that I need to respond to. Okay, so okay, guys, if you have any question, okay, fantastic. Oh, Jonathan, thank you for reminding me. That's great. Okay, so once you're done and you want to save your work, just go to File, and then come down to Download here, right? And then click Download IPYMB if you want to run this as a notebook. But if you're using VS Code or you're using PyCharm or anything that is not Jupyter Notebook, is not a notebook, you can use download as PY file. But if you want to run this next time on, say, maybe Jupyter Notebook, or you want to run it on Colab, you can just download as IPYMB file, right? For me, what you should send to me or send to the mail and for me to see is .ipymb file, because I will use Colab or Jupyter Notebook to view it. Yeah, so that should answer the question. Is there any other question I need to answer rather? And then yeah, so once you download that, that's all you need to um yeah. So we would send the email to you, the email that you can use to um the email you can send your py file, your .pymb file to, right? I cannot get to Colab. No, it's very simple. All you have to do is come to Colab. Make sure that you're logged into you're using Chrome, right? First of all, make sure you're using Chrome and then you're logged into your account here, right? This is your Google account or your Gmail account. And then you just come here and type in Google Colab. That's all. It brings you here. Click on Welcome to Google Colab. And it brings you here. And I presume this is the only thing you'll be seeing. Just Welcome to Colab. You could click this, or you could just click New Notebook, and then you get on Google Colab. Once you click that, to bring you to an empty page of Google Colab. You can revert to the assignments, the videos you've done before, and then that would help you go through that process. Okay, any other question? And I hope you don't have any issues. Enad, I hope you don't have any issues. I've answered Shegu's question. Ngozi, I hope you don't have any issues. Jane, no issues. Laumi, no issues. Um, I know, no issues. Right? Okay, so any other question, you could just send your question to the email that'll be put on the screen, and then I would get to answer your questions. And then hopefully for next week, we would actually have you come on stage and then share your screen, right? So you'd we'll get to code together on the screen, right? All right, so fantastic. Great having you guys here. So I'll be handing over to my co-facilitators to wrap this up. All right. Okay, I think we're trying to get. Okay, so yeah, you can see. Just submit your homework. Once you download it, submit it to hello@coderina.org. Right? Just send it as a mail, as an attached file in a mail to hello@coderina.org. Right? So again, you can send